Let's look at another example of using our reference triangles to find trig functions. So we're given that the sine of theta is 4 over 5 and the tangent of theta is less than 0. And we want to find the cosine of theta and the cosecant of theta. Okay, so let's go ahead and look at the sine of theta equals 4 over 5. Now if you remember, as we're going around our circle, or we're going through the quadrants, sine can either be positive or negative depending on where it is. And we learned that sine is positive in two quadrants. It can be positive in quadrant 1, and it can be positive in quadrant 2. And so if this were our theta, so this would be theta 1, and this would be theta 2. Now if this were if it was theta 1, then it would be opposite over hypotenuse, and if it was theta 2, it'd be opposite over hypotenuse. So notice that both of these triangles, they have positive y values, so it's, each of those has a sign that is positive and can be 4/5. So the next thing we have to do is we got to figure out, well, which of these two triangles is it? And this is where that tangent of theta is less than 0 comes into play. So if the tangent of theta is less than 0, this basically means it's negative. And there's two quadrants where tangent is negative. So the tangent is negative over here, and the tangent is negative over here. So it's quadrants 2 and 4. Alright, well now there's only one quadrant in which the sine is positive and the tangent is negative, and that's in quadrant 2. So we choose this quadrant right here. And so this is the triangle we're looking at. Right, so we can go ahead and rewrite this now. Here's our triangle. This is 4, this is 5, here's theta, here's our reference angle. And now we just have to find the cosine and the cosecant. Well, let's see here. The cosecant is easy enough. The cosecant is just 1 over sine, so it's 5 over 4. But the cosine, on the other hand, we need the adjacent over the hypotenuse, so we will have to use the Pythagorean theorem. So we have x squared plus y squared equals r squared. So we have x squared plus 4 squared equals 5 squared. So this is x squared plus 16 equals 25. So x squared is 9. And so we take the square root of both sides, and x is plus or minus 3. And if you recognized it, it is a 3, 4, 5 triangle, but anyways, we went through it. Now we have to choose, is it positive or negative? Well, in quadrant 2, the x value has to be negative, so we actually choose the negative 3 value. Alright, so now that we have the fact that that's negative 3, we can find that the cosine of theta is adjacent over hypotenuse, which is a negative 3 over 5. So there's our two answers. The cosine of theta is a negative 3 over 5. The cosecant of theta is 5 over 4. And there we have it. Let's try another one of these. Let's say we are given that the tangent of theta equals a negative 15 over 8, and 3 pi over 2 is less than or equal to theta, which is less than or equal to 2 pi. Find the sine of theta and the secant of theta. Okay, so let's go through the same exercise. We start off with a tangent of theta as a negative 15 over 8. And there's only two quadrants where tangent is negative. It's quadrant 3 and quadrant 4. And so we got to figure out which of these triangles applies. So this would be theta 1, and this would be theta 2. And for theta 1, let's see here, it's opposites over, so it'd be 15, 8. So this would have to be the negative, and this would be 15, 8, and that would be the negative. And so both of those have a negative tangent. So of course we got to figure out which triangle we're talking about, and this one's not so bad because it says theta is between 3 pi over 2 and 2 pi. So here's 3 pi over 2, here's 2 pi. So I mean it basically tells you quadrant 4. So here's our triangle. So let me draw that out. So here's 8, here's a negative 15, here's our alpha triangle. And we need sine. Of course, sine is opposite over hypotenuse, so in most of these problems you pretty much have to find the third part, so you might as well just go to the Pythagorean theorem. So we have x squared plus y squared equals r squared. So that's 8 squared plus a negative 15 squared equals r squared. Okay, so that's 64 plus, let's see here, a negative 15 squared is 225. So that's 289 equals r squared. And so r is plus or minus the square root of 289, which is actually plus or minus 17. So we got to figure out, is it plus or minus? Well, it's the radius, so it's always positive. The radius is always positive. Okay, so then we can figure out the rest of this. So the sine of theta is the opposite over the hypotenuse, so that's negative 15 over 17. Now the secant of theta, well, that's the same as 1 over the cosine of theta. So cosine is 8 over 17, right? So it's 1 over 8 over 17, so it would be 17 over 8. Because the cosine is normally adjacent over hypotenuse, so the secant would be hypotenuse over adjacent. There we go. So then we can write out the sine of theta is a negative 15 over 17, and the secant of theta is 17 over 8, and put a nice little box around that. Alright, so here's another good video on using the concept of circular trigonometry and which quadrant the terminal angle is, or the terminal ray is, in order to determine some trig functions. Not all 6 of them, but in this case we did a couple for each problem.